Welcome everyone. Welcome to Physics by Aaryan. I am very happy to welcome you all. In the last class, we discussed about center of mass. Now we will be discussing what is the motion of center of mass. So let's consider a body in which there are n number of particles. So each particle is moving with some velocity. So let's say m1 is moving with v1, m2 is moving with v2. Every particle has some sort of velocity. So you can consider it like a container which contains gas molecules. So each molecule has some velocity and there are n number of molecules. Now it is very difficult to study these kind of motions by studying the velocity of each and every particle alone. So this n can be a very huge number. It can be a very big numbers. So in physics, it is usually not possible to study the velocity of each and every individual particle and then do the analysis of the motion. Instead, what we do is we reduce the motion into the center of mass. So instead of taking all particles individually, what we do is we take the center of mass of all these particles. Now, in the last class, I told you, or I explained you, how we can find the position of the center of mass. Let's say all the bodies are rest, and then how do you find the center of mass of a body? But now what I'm saying is all the bodies are moving. Now what will be the velocity of the center of mass? Because if all the bodies are moving, then it means it is possible. It does not necessarily mean, but it is possible that might be your center of mass is also moving. So if your center of mass is also moving, let's say, then what will be the velocity of your center of mass? So the formula for center of mass velocity is m1v1 plus m2v2, so on, m1vn. Now here v1, v2, vn are the vectors. Okay, so these are the vector quantities divided by the total mass. So the same formula whichever was for the position is here also, but it is now for the velocity. Cm can also be written as the total momentum of the body divided by the total mass. So let's say somehow you know that what is the total momentum of the body, then you don't have to go and study the momentum of each and an individual particle. Simply what you can do is just take the total momentum and divide by the total mass, and whatever the velocity you are getting, that will be the average velocity or the velocity of the center of mass of your system. Okay, so the main point or the main idea that you should be knowing in your problem is the total momentum. You are not concerned about the individual momentums of the bodies. You are concerned about what is the total momentum of your system. If you know that, then you know the motion. So that is quite a simplification of a very complex problem. Okay, in first case, we have to see the velocities and the momentums of all the objects. But now what we can do is just find the total momentum of a body. Both the things will be same. Both will give you the same physics. Okay. Similar goes for acceleration. Let's say each particle is experiencing some force. If each particle has some force, it means each particle has some acceleration. If each particle has some acceleration, let's say first particle has acceleration a1, second has a2, and nth particle has acceleration an. Then if you reduce this problem into center of mass problem, let's say you don't want to study all the particles, but you don't only want to study one point, which is center of mass, then what will be the acceleration of that center of mass? Then the formula is quite simple, which is m1a1 plus m2a2 plus so on mn an divided by the total mass. Now, this can also be written as the total force divided by the total mass. So you should not be worried about what is the force acting on each particle, but you should only be worried about that what is the total force acting on a complete system. And if you know that, then you can know the same motion which you could know before. So if you just simply know what is the total force acting on an entire system, then your work is done. You can find out all the physics that you want. You don't have to worry about what is the forces acting on each and every individual particle. So these two are very deep physics concepts. These reduces your problems significantly. if you go to kinetic theory of gases, then you can actually understand all the results we are driving comes from these two postulates or these two formulas. Okay, similarly, we use these kind of problems in free electron theory when we explain that how the current is flowing or electrons are moving inside a conductor. Now there are infinite amount of electrons inside. How do we deal with each electron? So we just deal with their center of mass. Okay, so these kind of concepts are quite significant in physics. Okay, here F total can have two components. So force total. So what do I mean by total force acting on a system? So let's say you have a cylinder. Now this cylinder can have two kind of forces. Inside this cylinder, there are many gas molecules. So number one force on this cylinder can be, I apply some push to this cylinder. So this is F external. So if I push this cylinder, then this cylinder will move forward. But there is one more force involved, which is internal forces. What do I mean by internal forces? Now this molecule will exert force on this one, this will exert on this one, this will exert on this one. All the molecules are exerting force on each other. This force is known as F internal. So when I am showing F total, do I mean F internal plus F external? No. I only mean F external. Whenever I say F total, it only means F external. Why? Because internal forces always cancel each other. Always remember. You can think like this. If you have a cylinder at home, LPG cylinder, there are many gas molecules inside. All of them are exerting force on each other. But does your cylinder moves because of those forces? No. The cylinder does not move because of the internal forces between the gas molecule. It means your internal forces cancel each other and it has no effect on the motion of the center of mass. So I should write this line very clearly that internal motion or internal forces have no influence on motion of center of mass. This is a very important postulate, and I will explain that how do I use this postulate into solving the actual problems. Okay, so whenever I say F total is only meaning F external. So it means your F external or F total will be equals to acceleration of center of mass multiplied by M total. So your F external equals to M total into acceleration of center of mass. So this is your reduced second law. Reduced second law. So instead of applying second law on all the particles, you can just apply center of mass on the center of mass. So just apply a second law on center of mass. That's it. You don't have to apply center of mass on all the individual particles. So this is a simplified physics. This we can say as method to reduce a complex problem into a solvable problem. Okay. Okay. So what if no external force is acting? Let's say there is no external force acting. So you have a cylinder. I will again come back to this example again and again. You have this cylinder and you are not pushing the cylinder from outside. So there is no external force. It means the total momentum of this cylinder will also be zero. So this cylinder will not be moving. However, the individual molecules are moving. So momentum of individual particles are changing. They are moving. Their individual particles are moving. They are experiencing collisions. Their momentums are changing. But the momentum of your total body will not change. So if it is at rest, it will remain at rest. If it was moving in the uniform velocity, it will keep on moving with the uniform velocity. So if your external force is zero, then the total momentum of the body will also be zero. Okay. However, the individual bodies can change their momentum. Okay. So if you have a two-body system, then the individual bodies can change their momentum, but the total momentum of the body, both the bodies will remain same. Okay. So this is a concept that you should remember. And we will be using this concept quite a lot, especially in collisions. The next topic which we are going to cover, which is collisions, this theorem will be the basis of that. Okay. Now, I want to give you some examples in which the bodies are actually moving, as I mentioned, but the center of mass is at rest. Center of mass is not moving. Center of mass is at rest, but the individual bodies are moving. Their individual momentums are changing, but the total momentum remains zero. So first example is body at rest. So if entire body is at rest, then the center of mass is also at rest. Very simple. That is not something very interesting. Let's come to second part. Second part is there are two bodies. One is body A and another is body B. Body A has a mass of 2m and body B has a mass of m. Body A is moving to right with the velocity of 2 meters per second and body B is moving to left with a velocity of 4 meters per second. What is the momentum of body A? Mass into velocity, which is 4. And what is the momentum of body B, which is mass into velocity, which is m into -4, which is -4. So what is the total momentum of the body, which is 0. So however, your individual bodies are moving, A and B both are moving, but your center of mass will not be moving because the total momentum is 0. Okay, so the center of mass will remain fixed. Your bodies are moving, but the center of mass will remain fixed here. It will not move. So can you tell me, will it be here or here? Will it be close to 2m or will it be close to m? So as I mentioned in the last class, the center of mass is always closer to the heavier body. So your center of mass will be somewhere here and it will remain fixed. It will not move. However, the individual bodies are moving. Okay. Third is even more interesting. Let's say you have a bomb. It's a Diwali festival coming up and then you have a bomb and you explode that bomb. You put that bomb on fire and that bomb explodes. Now this bomb explodes into 4 parts, M1, M2, M3, M4, and all of them has some velocity. But the center of mass will remain at rest. The center of mass initially was here in the middle. So your initial center of mass was here. Even after explosion, it will remain here. Why? Because explosion means internal forces. No one has done anything from external. Explosion in itself means internal forces. So internal forces does not influence the motion of center of mass. It means the center of mass, if initially was at rest, still it will remain at rest. So it's a very interesting problem and we will actually be using this to solve the problem. Okay. Now, what if the center of mass was moving? Let's say your center of mass was moving with uniform velocity or whatever, your center of mass was moving, or let's say your bomb was moving. So your bomb was moving like this. Let's say this is your bomb and it is moving like this. And in the halfway, the bomb explodes. Here the bomb explodes into 2 parts. Your center of mass will still keep on going in the same direction in which it was going. So if this body wouldn't have been exploded, then what would have happened? Your body would have gone like from here to here. But now what happened? Your body exploded or your bomb exploded in middle and it exploded into 2 parts, one here and one here. But your center of mass will still keep on moving in the same direction. Why? Because the explosion is an internal force and internal force does not influence the motion of center of mass. So your center of mass will keep going in the same trajectory as it was going before. So always remember this. If center of mass was initially at rest, then it will remain at rest. But if center of mass was under some trajectory, it will keep on following that trajectory. It will not change its trajectory because of the explosion. Okay, so this is a very important concept in physics, and this is used extremely very much in satellites, rockets, and all those kind of applications. It is even used in the nuclear and particle physics to predict many things. It is used in quantum mechanics. So this concept is extremely important. Many times in physics, especially in CSIR, NET, IIT, JAM, these kind of exams, I will be discussing center of mass frame. I will be talking about the things like center of mass frame. Why we prefer to talk about center of mass frame? Because center of mass frame is not influenced by the internal forces. Okay, very important concept. Another example where center of mass is not changed is a boat. So let's say you are in a boat. So inside a boat, let's say boat is at stationary, it is at rest. So many people are moving inside a boat, but the center of mass of the boat will remain fixed because all the people moving are like an internal forces. So it will not influence the center of mass of the boat and boat will remain at rest, or boat center of mass will remain fixed. But all the people inside the boat are moving. Okay, very nice. So let's try to solve a problem using the concept which we learned just now. So there is a body which is projected with the speed of 100 meters per second in motion in 2 dimensions. We discuss in detail how do we study the motion in 2 dimensions. Projectile, we studied the motion of projectile. So what I want to teach you right now is there is a bomb which is moving, which is projected with 100 meters per second at an angle of 37 degree precisely. And at the top point, when it reached the top point, it explodes. So it explodes into 2 parts. One part has a mass. So both the parts has a mass of 1:3. So both parts has a mass of 1:3. So if the first part has a mass m, then the second part will have mass 3m. So the smaller part come to rest. So what happened when it exploded here? The smaller part come to rest. If it come to rest, what will happen? It will come down and fall to the ground. So if something is at rest here, what will happen? Gravity will pull it down and it will come down and hit the ground. So what happened to smaller mass? Smaller mass came here and hit the ground. What about the center of mass? As I mentioned, explosion is an internal force and it will not influence the trajectory of the center of mass. So center of mass will keep going in the same direction. And center of mass will finally hit the ground here. What about the bigger mass? So if smaller mass is here, center of mass is here, then it means your bigger mass has to be here, right? There is no doubt in this, right? Because center of mass is close to the bigger mass, right? So your bigger mass has to be here. So your bigger mass will somehow go here and hit here. Okay, so this is what is going on. So can we locate the position of center of mass? Can we find out where is center of mass sitting? Yes, we can. How? In the last class, in the motion in 2D class, I explained you what is a range. So this is exactly the range, right? So how do we find the range? So the formula for range is u square by g sine 2 theta, or u square by g 2 sine theta cos theta. What is u? U is 100, which means u square is 10 to the 4. What is g? G is 10. 2 times sine 37 into cos 37. Now I want you to remember these values. These are very important. Many times in physics, you have to use sine 37 and cos 37. So sine 37 is 3/5 and cos 37 is 4/5. So if you put the values of these sine 37 and cos 37, the range you will get is 960. It means your center of mass is at 960. And the small mass will be halfway, which is 480. It's very simple. If the entire range is 960 and the highest point is in the middle, then your small mass is at 480. Now the question which is asked to you is, what is the position of this bigger mass? So let's make a simple diagram. So your center of mass is at 960, your small mass is at 480, and your bigger mass is at x. Let's see. And we want to find this x. What is the formula for x center of mass? It is m into 480, m into x plus 3m into its position, which is x. So 3m into x divided by total mass, which is 3m plus m, which is 4m. And what is your center of mass given? Center of mass given is 960. So if you do a very simple mathematics, what you can find out is your x is 120 meters. It means your bigger mass is at 120. So you can clearly see that your center of mass is close to your bigger mass. Okay, so very interesting phenomena which we studied. So you saw how we use the analysis that center of mass is not influenced by internal forces. We used that analysis and we solved a problem which otherwise could have been very difficult to solve. Okay, so this is what I wanted to teach you. Let's do just one more example and then we will be done with the lecture. And let's see our example very carefully. There are two masses. One mass is m1 and another mass is m2. So m1 is coming in this direction and m2 is coming in this direction. So initially what has been asked is, what is the initial center of mass velocity? So let's say they have not collided. So by the way, they will collide at the origin. So they will come and they will collide here. It is given in the question. They will collide at origin. But before collision, what is the velocity of center of mass? This is asked. So let's find the initial velocity of m1 and then let's find the initial velocity of m2. So initial velocity of m1 means what is the next component of initial velocity of m1? So if this is your v1, then your x component will be v1 cos 37. And since it is in negative side, you will say minus v1 cos 37. So minus v1 cos 37. I just gave you the value of cos 37. v1 is given to you, which is 5. So if you put the value, you will get minus 4. Similarly, if this is your v1, then what will be the y component? It will be minus v1 sine 37. So it will be minus v1 into sine 37. So you can put the value and you will get an answer of minus 3. So if your x component of velocity is minus 4 and your y component of velocity is minus 3, what will be the vector? Minus 4 I cap into minus 3 j cap. So this will be your initial velocity of v1. Initial velocity of v2 is very simple. It is simply going along z-axis. There is no x component. It is only going in y. So your second velocity is 5j cap. So you know u1, you know u2. How do you find u cum? You know m1 u1 plus m2 u2 divided by m1 plus m2. So if you simply put the values of mass and velocities, you will get a very simple answer of minus 1.5 I cap plus 2j cap. It is very simple to do. Anyone can do this simple mathematics. Okay, so this was a good approach to solve the problem. Now what happened is the collision has happened at the origin. So both the bodies came and collided. Now I want to repeat the same thing. The collision is an internal force. You can assume that there are two molecules and they collided. So this will be an internal force. No one externally has came and put any force on these two bodies. It means the velocity of their center of mass will remain same. So the final velocity of center of mass will also be same. So v cum, which means final center of mass velocity, will be equals to u cum, which means initial velocity of center of mass. Now, what will be the position? So what is the question asked to you? Find the position of center of mass after 2 seconds. So how much distance it will cover? So S equals to ut. It's a very simple formula. So u cum, you know, you have find it in the previous question, and time also you know, which is 2. So if you multiply these two things, you will get your answer as minus 3 I cap plus 4 j cap. So this was about the position of your center of mass. So I made a very relevant points in this lecture. I think I will also share the notes in which all this discussion has been done very nicely. These notes are very, very brilliantly written and has all the examples which I have discussed. So you should look at these notes, and mainly you should also focus on covering all the quizzes which I have given before, because still many students are messaging that they need some more time to complete the quizzes. So please take your time and complete the quizzes as well, because quizzes will actually make you a very good student, and it will help you grasp the concepts even more. So go to our website or an app and solve all the quizzes. The quizzes for foundation physics are completely free. Anyone can participate on those quizzes and take the quizzes. All the quizzes are fully solved. So once you solve the questions, you will get the solutions of that questions as well. So I hope that your concepts of center of mass is now clear. In the next class, I will go on teaching the collisions. So collisions is also a very important part. So especially in JAM, JEST and TIFR, if I talk about the collision question comes every year. So let's meet in the next class. See you then. Bye bye everyone.